This video explains how to apply an analysis of variance in the R programming language. First, we will apply this method to some example data, and then we will evaluate our results using a Tukey's HSD test. We will visualize our results, and we will also check certain assumptions, such as the normality of our data and the homogeneity of our variances. So without too much talk, let's dive right into the R code. As a very first step, we need to install and load two packages that we will use in this video, and these packages are called ggplot2 and car. So the ggplot2 package is used for data visualization, and the car package is used for certain post-hoc tests that we will apply to our ANOVA results. I have installed these packages already, so for that reason I don't need to run lines 2 and 3 of the code. However, if you don't have installed them yet, please run these lines of code, and then in the next step we would have to run lines 5 and 6 of the code to load the packages into our current R session. So after running these lines of code, we can apply the functions of the ggplot2 and car packages. In the next step, I want to load our example dataset, and in this video we will work with the mtcars dataset that can be loaded by running line 8 of the code. So after running this line of code, you can already see that mtcars is appearing at the top right, and we can print the first 6 rows of this dataset using the head function, as you can see in line 9. And then you can see at the bottom in the RStudio console that the mtcars dataset contains different cars and then different information about these cars, such as the MPG, the cylinders, and so on. Now, in the next step, we also want to prepare our data for the ANOVA by converting the cylinder category to a factor class, because if we work with categorical data, we usually have to use the factor class. And for that reason, I apply the as.factor function to this column, and then I update this column in our mtcars dataset. So after running this line of code, the cylinder category is converted to the factor class, and now we can move on to the ANOVA, and we can apply an ANOVA in our programming using the AOV function. And within this function, we have to specify a formula. So in this case, we want to test if there are any differences in the MPG column based on the groups in the cylinder column. We also have to specify the name of our dataset, which is in this case mtcars. And then I store the results of the analysis of variance in a new data object that I call ANOVA result. Please note, I have created a more comprehensive course on statistical methods in R programming, in which I will also discuss analysis of variance. And in this course, we will also speak more about the theory behind this method, and you will also get more details on how to apply the method in R programming. So if you are interested in this and related topics, make sure to check out the course, link in the description below. So after running these lines of code, you can see at the top right of RStudio that a new data object called ANOVA result is appearing. And now we can apply the summary function to this data object, as you can see in line 15 of the code, to return some results of our ANOVA. And as you can see, the p-value is almost 0, which means that there are significant differences between our groups. However, at this point, we do not know which groups are different. So it could be that some groups are not different, but others are significantly different. And for that reason, the next step is to apply a TukeyHSD post-hoc test. And we can do that by applying the TukeyHSD function to our ANOVA results, as you can see in line 17 of the code. In this case, I store the output of this in a new data object called Tukey result. And after running line 17 of the code, you can see at the top right of RStudio that a new data object called Tukey result is appearing. We can also print this, and then you can see at the bottom in the RStudio console that we have applied a TukeyHSD test. And now you can see here, based on this table, in the right column, that all of the group differences are significant, because this gives you the p-value for each group-wise comparison. So as you can see, the cylinder column contains 3 different groups, the values 4, 6, and 8. And now you can see that if you compare the cylinder groups 6 and 4, there's a significant difference. If you compare 8 and 4, there's also a significant difference. And if you compare 8 and 6, there is also a significant difference. Now, in the next step, we can also visualize these TukeyHSD results using the plot function. So as you can see, after running lines 20 and 21 of the code, a new graph is appearing at the bottom right. We can enlarge this plot, and then you can see that we have created a confidence error bar for each of the group-wise comparisons. So once again, at the top, we compare the groups 4 and 6 cylinders. Then we compare 4 and 8 cylinders, and we also compare 6 and 8 cylinders. And as you can see, none of these confidence intervals is overlapping 0. And if this is the case, then our differences are statistically significant. In the next step, I also want to visualize our groups to show the differences even better. So as you can see in lines 23 to 29 of the code, I'm using ggplot2 functions. So first I use the ggplot function to draw a plot of our dataset mtcars. And within the aesthetics of this plot, I specify that I want to show cylinder on the x-axis and MPG on the y-axis. Then I specify that I want to draw a box plot, and I also change the titles of our plot. So after running these lines of code, you can see that a box plot is appearing at the bottom right. We can enlarge this plot by clicking on the zoom button, and then you can see that we have our 3 different categories, 4 cylinders, 6 cylinders, and 8 cylinders on the x-axis, and each of these categories is represented by a box plot. And then you can also see that the medians of these groups are very different. However, one suspicious observation is here that the variance of group number 4 seems to be much larger compared to the other 2 groups. And if you apply an ANOVA, then certain assumptions have to be met, such as normality of the data and homogeneity of the different variances. So for that reason, we also have to check if the assumptions of the ANOVA are met by our data. And one important check for this is to test for the normality of the residuals of our data. And we can do that by running line 31 of the code. So in this case, we apply the plot function to our ANOVA results. And we also specify the value 2 to create a QQ plot. So after running this line of code, a new plot is appearing at the bottom right. And if we enlarge that, we can see that we are plotting the theoretical quantiles against the standardized residuals. And in this plot, you can see a straight line, and you can see the corresponding values. And if we would have normally distributed residuals, then these values or these data points would be close to the straight line. However, you can see that some of the values are not close to the straight line, and for that reason, we would assume that our residuals are not normally distributed. So this is already a violation of one of the assumptions of ANOVA. Another test that we can apply is the Levene test that you can see in lines 33 and 34 of the code. So the Levene test checks for the homogeneity of the variances in our groups. And within the Levene test function, we have to specify the target variable MPG and our grouping variable and our dataset mtcars. So after running lines 33 and 34 of the code, you can see at the bottom in the RStudio console that another output is returned. And here you can see that the p-value is very low, so below our threshold of 0.05. And this means that there's no homogeneity of the variances between our groups. And this is another violation of the assumptions of the ANOVA. If you would like to learn more about the other methods that overcome these problems with violated assumptions of the analysis of variance, then make sure to check out my online course on statistical methods in R programming below in the description of this video. Thanks a lot for watching and see you soon. Bye bye.